1.9. Well, I mean, you realize the magic math I'm doing. I mean, I'm calling, that's 1, right?
Right.
That's 1.
Yeah.
And then I find a common denominator. And I'm like, it's close to 1, call it 1. Magic. Now, the answer actually is going to be 2. The reason that you're getting 1.9 is because that distribution does go off to infinity. Which means the 7 and the 128 and the 8 and the 1 over 1, whatever, 256, whatever's next, that does contribute something towards the average, just like the Gambler's Ruin did. But we'll make a quiz for this for next week if you want to look at it more deeply. Cashy's like, yes, I will look at it. That's okay. It's totally fine. Totally fine. But if you're interested in the math behind it, it's fun math. It's fun mathematics, watching you go off to infinity. Friends, those of you guys that ran one of our stats, what was your n at the bottom of that? N equals 0.9. 0.98? So we're missing 2%. That's what that's telling you. That 0.98 would be all of these added up. And you remember what they have to add up to in a distribution? 100%. We're missing 2%. The extra 2% is going to contribute the last 0.1 to the average. So we'll have I'll build a quiz for next week. You guys can play with that if you want to, which of course you don't have to. Okay. Now, the question is, we've stated the question. On average, how many pulls should it take until we get out of here? Well, there's my population. Here it is. Okay, Linda, you're close. Let's shuffle over again. So what we're doing, Rory, is we're answering your question too. Your question was an awesome one. What's the difference between 243 and 244? You just did some freaking awesome 243. Yeah? That's a 243 right there. Distribution, average of a distribution, right? It's going to be, I didn't ask you guys on the standard deviation, did I? Because I don't really want to talk about it. Because what kind of a distribution is that? Highly skewed. Oh, there is. There's a population standard deviation right there, the 1.18. It's a highly skewed distribution. Notice the probabilities: 1/2, 1/4, 1/8, 1/16. If you actually look at the graph of that, it's perfectly exponential, which means the standard deviation is going to be skewed because of those outlier events at the far right of the graph. So average 2. So Linda, here we go. Red card, we're out of here. Boom. 2. Spades. Can't leave yet. 2 spades. What's the chance of that happening? What's the chance of us pulling 2 black cards in a row? What's the chance of us pulling 2 black cards in a row? We actually answered it earlier. It's the same as the chance of pulling a black card followed by a red card, isn't it? It'll be 25%, yeah? Does that make sense? This is a 243 question again, Roy. I love your question earlier, by the way. It's a 243 question, right? If you pull a card and then a second card, the chance of them both being black is the same as the chance of them both being red. 25%. 50% of the time, they're going to mismatch. Black, red, or red, black. That's at 50%. One of them is right there, the 1 and 4. Is that fair? Yeah. Tell me if it's not fair. Okay, I'm feeling good now. Feeling good, Julie. Here's population. Fanned out. Jack of spades. The questions begin. The questions begin. The question: have I messed with the deck? Cassidy's not convinced back there. Did I mess with the deck? Who asked me that? Joe, did you ask me? Did you call me?
Did you or did Max?
I can't speak for Max. I tried. Ace of clubs.
Does it make a difference that you're letting them pull from anywhere in the deck?
Well, it shouldn't. I'm shuffling as we go. I suck at shuffling the flippy way, so I'm doing it this way.
Can you think? I'm going to turn them this way so we can see the.
Well, then, would this be inferential statistics anymore? Would this be inferential statistics anymore if I did that?
Could we see half the population?
You can see a sample from the population. No, but let me ask you a question about that. Let me turn that back. Hang on a second. I'm going to have Frankie draw next. When half the population seems very, if we could get half the population, it'd be freaking awesome, wouldn't it? The problem is, what's your population? In this case, it's a deck of cards. But what's a normal population? Give me a population that, say, a psychologist would be interested in studying.
40,000.
No, give me not a number, but what population would they be interested in studying? For example, schizophrenic patients. How many schizophrenic patients are there? Give me a number, because I don't know the number.
20,000.
20? That's it? Really?
I don't know.
Only 20,000? Wow! I didn't know that. Okay, I was thinking it was much larger than that. But even getting half of them, how much would that cost to get half of 20,000? I mean, do you see what I'm getting at here? Very often Gallup runs polls on voters in America. Voters in America. How many voters are there in America? 150 million? You can't get 75 million. What does Gallup get? about 1,000 or 2,000 tops. So the question is, what the hell kind of data can you get from 1,000 out of a population of 150 million? And the answer is pretty damn awesome. That's the point of Math 244. You can get a lot of good data. You can get a lot of good data from a very small sample as long as your sample is drawn nice and randomly. Yes, which we've spent a lot of time analyzing this course too. Yeah, you can get a lot of good data from a very small. Good Lord, you guys did it last term. Remember those dice?
Yeah.
Remember your sample size on your in-class quiz last week of term? Remember how small it was? What was your sample size? You don't remember. 2 weeks ago. 2 weeks ago. It was a long time ago.
I remember we were orange.
4! You drew a sample of size 4, and from a sample of size 4, you guys nailed the average. Freaking awesome! 4! No statistician in their right mind would ever use a sample of size 4. They'd use at least 40 or 50 or something like that. But you still were able to do good math with a sample of size 4. Let's go to sample of size 5, though. Sample of size 5. Party, have you drawn yet?
No.
She draws
Oh my gosh.
10 spades.
God.
The deck has been messed with, claim number 1.
Isn't that the type 244? We can't see the population.
That's the whole point. You can't see the population. All you've got is the sample you just draw.
So there's only an outlier in there, right?
Well, so, isn't there a chance that the deck has not been messed with?
Yeah.
What is the chance, based on this data, that the deck is probably fine? You could have easily drawn 5 black cards.
Wouldn't it be 1 in 16?
It would be 1 in 32, wouldn't it?
Yeah.
It'd be 1 in 32, because you guys pulled 5 cards. And if you pulled 5 black cards every single time, it'd be a 1 in 32 shot. I understand that you're saying this is until red, but that would be the same probability for a black card followed by a black card, followed by a black card, followed by a black card, followed by a black card. Please.
Does this have anything to do with the rare event rule?
It kind of does, doesn't it? Because the only explanation for this deck being fair would be that we just saw a what? What did you guys just say? If this deck is fair, what did we just see?
An outlier.
We just saw an outlier, didn't we? If this deck is fair, because we don't know if the deck is fair. That's the whole problem. We don't know if the deck is fair or not. All we know is you drew 5 cards from the deck, and we got 5 black cards. That can happen, yes? That can happen with a fair deck. But what's the chance of it happening from a fair deck? We just calculated it. 1 in 32, which is like 3%. So that rare event rule, quote it for me if you would, Melanie. I want to make sure I use the right phrasing.
If and only if your p-value is greater or less than something.
Okay.
I don't.
Oh, okay.
I took it a couple terms ago.
Oh, it's all good.
I can't quote it verbatim.
So, in other words, if something is an outlier, it's got a small probability. That's what you guys are calling what just happened an outlier, yes? 5 black cards from a fair deck is an outlier. One of the definitions of an outlier from 243 is something that doesn't happen a whole lot. Well, that would be 1 in 32, yes? Did anybody get pissed when Austin pulled the black card first?
No.
Anybody get upset? Why? Because it happens half the time. Anybody get pissed when we pulled the second card as black as well? Nobody really got pissed there either, did they? How about the third? Oh, I was right there. I wanted to leave right then.
I was mad at the
I want to get the hell out of here. How about here? This is actually when the question started. The question started here. Wait a minute. I think Jolene, you said you messed with that deck. Because you pulled the third card, didn't you? Yeah, you did. But that's 12.5%. But what's happening is it's getting half as likely each time that you see the black card come out again. And at some point you have to say, wait a minute, this is unlikely. It's unlikely that we see all those black cards. I have something I want to show you that might change your mind. Maybe. It ties to this rare event rule. You made me think of it, Melanie, when you said that. It's okay. I want to show you something and see if see if this is a counter to your argument. Okay? Hang on one sec. Let me find it. 44. Oh, there you are. You can't see it at all. So there's 200 cards drawn from a fair deck. Down here, I've kept track of the proportion of reds and blacks. There's 55% red, 46% black. I know it doesn't sum to 100%. It's because Excel can't count sometimes. All right? So here's 200 more. 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 The reason I'm showing you this is I see an awful lot of runs of 5 or more black cards in that. Don't you? Right now, I sit top row, second row, like halfway down the left side. There's a lot of black cards in a row, aren't there?
Yeah.
How about right there? How about right there? How about right there? See, so does this change your argument about what we just saw? It shouldn't. You should still have the same argument. You should still be pissed. Why? If I'm showing you a bunch of black cards in a row, why should you still be pissed? Alan?
Well, my thought is, you wouldn't have made a point if the cards were a real.
I didn't make a point, you guys did.
Well, I know, but if you would have pulled the red card, the very first card,
That's true.
You wouldn't have been able to make your point. So.
Oh, I know I had a point. I know I had an agenda.
Please pull the screen down.
This guy, I love this guy. Why should this not disprove the fact that you guys are pissed? I love what you're saying. I would just pull the screen down. I actually had this left over from 243. You guys saw this almost the exact same thing at the beginning, 243. But
Is it because there's like 200? So obviously out of 200, you're going to have a group of black and a group of red, and they're not just going to be black, red, black, red, black, red.
and that's what it was in 243. That's why you made me think about that when you said that. Because in 243 we talked, well, you have 200 coin flips. You're going to expect runs of heads and tails at some point in the 200. Where did we get our 5 black cards?
The beginning.
In the beginning. Watch the 5 first cells. Let's call this, what do you want to go across or down? Up to you guys. Across. 1, 2, 3, 4, 5. Watch those. Okay.
What is this?
What is this craziness? Where are your guys' results?
They're not in the first.
Oh! How many was that? That was like 30, wasn't it? 25? Something like that? Well, I think we're proving the point right here. Aren't we? I think it's just like, yes, you proved it like 10 minutes ago. You're just kicking a dead horse at this point. Should we have seen what we saw? Should we have seen what we saw? If this deck is fair. If this deck is fair, then we should not have seen 5 black cards come out in the first 5 cards. So therefore our claim would be,
He's not fair.
well, let's not be judgmental. The deck is not fair. Let's be objectively non-judgmental. That's 244. 243 is doing what we did back here.
Everything's red.
But 244 is saying, assuming everything's fair, what's the chance our data comes out the way it did? In this case, almost none. Almost no chance of that happening. That's 244, Rory. Does that make sense? And if it doesn't, we'll revisit this again on Thursday. Okie doke? Have a great rest of your day. It looks like it. Well, it's still snowing. Let's slow down a little bit. Travel safe, my friends. We'll revisit the cards.